Hello, and welcome to the Economy, Land and Climate podcast. My name's Alasdair McEwen, and in this episode, I spoke to John DeCicco, Emeritus Research Professor at the University of Michigan. John's an expert on energy and climate in the transport sector, and we spoke about his extensive research and skepticism of using plant-based liquid fuels, or biofuels, as a climate solution.
We're looking at a world that is in a climate crisis. We've been talking for many years about what we need to do by mid-century. There's no way that the carbon debt from the biofuels being produced now is going to be repaid by 2050.
I began by asking John how and when he began researching biofuels.
I have spent the last 30 years of my career largely focused on transportation, the bulk of my career. I worked a lot on vehicle efficiency, improving the fuel economy of vehicles. I was, very involved in doing analyses that supported stronger regulations for vehicle efficiency. But also in the course of that work, I began to pay more attention to the fuels side of the equation. And, the 2000s rolled on. We had another energy crisis due, initially the Iraq War, again, Middle Eastern oriented, unlike this Russia-centric energy crisis. During that period, here in the 2000s, and similarly in Europe, the interest in biofuels really ramped up. Like a lot of people at that time, I assumed that biofuels were inherently carbon neutral. This is the notion that the CO2 that's released when you burn a biofuel is fully offset, fully balanced out by the CO2 drawn from the air when the feedstock plants grow. I noticed you have previously done a podcast with Professor John Sterman at MIT. I've actually never met him, but we have corresponded over the years and things like that. And he talked about the problem with respect to forest bioenergy. Well, that trees don't regrow overnight. It takes a long time. In the case of liquid biofuels, such as ethanol or biodiesel, those are sourced, in fact, almost exclusively to date from annual crops like corn or maize, as it's known, soybeans, other seed oils, rapeseed, depending on the area. The assumption there is, well, hey, those crops just regrow every year. So we don't have this long-term complication that you have with forest bioenergy. So this carbon neutrality assumption, isn't it obvious that biofuels made from annual crops simply recycle carbon? As people began to scrutinize that, certain parts of the scientific community became aware, but growing biofuels takes land. And so when you take some of the harvest that was previously used for food or feed and divert that to biofuel, there's going to be a ripple effect that might aggravate land use change, i.e. tropical deforestation, which is already happening because of just human population expansion, demand for more food, and more people as wealth increases eating higher on the food chain, which means you then are growing cattle to feed ourselves, and cattle, themselves need pasture land and lots of feed. Our human consumption system is already very land intensive. And so if you begin burning some of those crops, you're going to need to compensate, and that aggravates deforestation. Another colleague of mine, we actually overlapped at the Environmental Defense Fund, a fellow by the name of Tim Searchinger, now at Princeton, did a seminal study in 2008, essentially characterizing this ripple effect of land use change internationally. It came out in the same issue as a parallel study that looked at direct land use change. And this has been happening certainly in the United States, where prairies get plowed under to make way for more annual crops. So that's a direct effect in contrast to, say, this ripple effect that international land use change, or so-called indirect land use change, other people talked about. All that got me thinking about the way people have been modeling this. The methodologies have not been quite right. And in response to these land use change concerns, the models that were used to address biofuels were complemented by models that looked at commodity crop markets and their resulting effects on the demand for agricultural land to characterize that. And they got even more complicated. The result was a lot of uncertainty about what's really happening. That provoked me to do a deep rethink of the fundamental assumptions. And I zoomed in on this assumption that biofuels are inherently carbon neutral. Even though it is very widely used in modeling, it's actually official policy in the European Renewable Energy Directive. The documentation there declares biomass as carbon neutral. Similarly, in the United States Environmental Protection Agency, which administers the renewable fuel standard here, which we colloquially know as the ethanol mandate, makes the same assumption, as does California for its so-called low carbon fuel standard. So I began scrutinizing that assumption. Actually, Tim Searchinger in 2010 wrote a very insightful paper in which he questioned that assumption. I began picking it apart, and the insight that I came to was that biofuels are not inherently carbon neutral in the common sense of the word, where their regrowth of the feedstock just recycles the carbon. And let me try to give a simple explanation of why. Let's go back to the land on which plants are growing does with respect to the carbon cycle. Growing plants photosynthesize, they remove CO2 from the air. If you think about that in terms of land, if you have a given area of land, you can think of that as a sort of an immediate sink. It's not necessarily a permanent sink. If it's a forest that's left to regrow, indefinitely, it can be that kind of a sink, provided a forest fire doesn't come and wipe it out later. But for annual crops, which are those of concern for liquid biofuels, it's an annual sink in the sense that it's pulling CO2 out of the air. Like we think of crop yield in terms of tons per hectare harvested, or in the United States, we use bushels per acre. And let's take corn, so many bushels per acre get harvested. All biomass contains carbon. You can, in a straightforward way, convert that harvest to a carbon sink strength of so many tons of carbon per hectare being drawn out of the air. For instance, when you do that calculation in the United States for typical corn yields, if I'm recalling my numbers correctly, it comes out to be about a little over 4 tons of carbon on a carbon mass basis per year getting pulled out of the air. Let me go back to the biofuel situation. Suppose you have a cornfield, and last year it was growing corn, it's being harvested, it's removing CO2 from the air at a given rate, say 4 tons per hectare, and that's going into the food system. The carbon gets respired either by the cattle that eat it, or ourselves when we eat the cattle, or if we eat the corn directly, whatever. And last year, that's all the corn from that field is going into the food system, and we're burning fossil fuel, petroleum, petrol product in the cars. Now, suppose this year we take the corn from that field and divert it to make ethanol. Ethanol gets burned in the cars instead of the petroleum fuel. From a chemistry point of view, when you burn any liquid fuel, the amount of CO2 that comes out the tailpipe is about the same within a couple of percent. So directly substituting ethanol for petroleum fuel does not reduce the rate at which CO2 is flowing into the atmosphere. Now let's go back to that cornfield. Is it sucking CO2 out of the atmosphere any more quickly this year than it was last year, just because we're using its harvest differently? No. So when you look at it in terms of what's going on the land, that actually, to first order, biofuels aren't carbon neutral at all because you haven't changed anything. That area of land is still pulling CO2 out of the air this year at the same rate it was last year. The CO2 coming out of the tailpipe is happening at the same rate this year as it was last year. So you say, whoa, wait a minute, what's going on here? What this ended up pointing me at is like, aha, when people were looking at this whole carbon neutrality thing, they're looking at it in a very static way. And you need to do a dynamic analysis. And this is what Professor Sturman did. His specialty is system dynamics. I wasn't a specialist in that, but I was trained as an engineer, so I was very comfortable with dynamic analysis. And I said, aha, we really need to do a dynamic analysis here. So that's, the nature of the work that I began doing 15 years ago now when I began piecing this together. So when you do that kind of a dynamic analysis, the picture is not as simple as this notion of carbon neutrality that's baked into all the traditional models that it just recycles. And you really then have to look at what happens when you take a harvest and divert it for biofuel. And then a bunch of things happen that I don't want to necessarily get into at this part of the conversation, but we can touch on later. Anyway, that was kind of the progression of my thinking, as my interest evolved into climate and then the transportation part of climate and then the fuels part of that equation. And then the fact that biofuels were embraced by many policymakers and many green groups as an important solution based on this, what turned out to be simplistic and scientifically incorrect notion that the CO2 released when a biofuel is burned is automatically and completely recycled when its feedstock is grown, which turns out not to be true.
Can I ask you about definitions of biofuels, just for our audience? I know there are quite a few different interpretations of what biofuel is, and it's used in very many different contexts.
Yeah, well, the broadest definition of a biofuel is any fuel used for energy that's derived from any form of biomass. In subsistence-oriented societies, people harvest dung from their pastures, dry it, and use it. And so that's an example of a traditional biofuel, and wood traditionally used for heating and cooking and so on. So the broadest definition is any form of biomass. When we're talking about contemporary energy and our industrial energy systems, we've come to typically use a term like forest bioenergy for wood that's harvested to, say, replace coal in electric power plants. We now tend to use the word biofuel to refer to liquid biomass-based fuels designed to displace petroleum fuels. It's that more narrow definition of biofuel, a industrially produced biomass-based liquid designed for use in modern transportation equipment, for which liquid fuels are most convenient. Some people also think of biogas as a biofuel. You can make biomethane in various ways. You can use it for power generation directly for heating, or you can burn methane in motor vehicles as well. But of course, biogas is not nearly as convenient for motor vehicles. The whole idea why biofuel mandates were put in place in the United States, other countries, why part of the Renewable Energy Directive, supplemented by they're what as your fuel quality provisions, or which refer to the liquid fuels, have had a biofuel mandate, really refers to industrially produced liquid biofuels such as ethanol from corn or wheat, or biodiesel, primarily from various oilseeds.
Can you give us a picture of where we are in terms of biofuel development, if that's possible?
After this, energy crisis-driven burst of policymaking activity that happened in the mid and late aughts, biofuel use globally has increased rapidly. Now it's, I would say, increasing at a more kind of steady rate. Even though questions have been raised throughout this whole period by scientists critical of the assumptions behind the traditional modeling, policymakers, for the most part, have maintained their prior analyses supporting the use of biofuels as part of a climate mitigation strategy. The United States, being the voracious consumer of everything that we are over here, U.S. ethanol is the single largest component of that. But biodiesel use has been increasing steadily as well.
Are you essentially saying that, for the most part, biofuels are worse for the climate than the fossil fuels that are displaced by using them?
To date, yes, that's the case.
And can you say a little bit more about why that is? I know you went to it already, but a little bit more detail on that would be very interesting.
When farmers go to look for new land to grow crops, to put new land into production, it's happening on a frontier somewhere. They don't go to a desert. They're not displacing barren land. They're displacing forests or prairies or something. And those natural lands are pulling CO2 out of the air anyway. So you've lost some of the natural sink. The far bigger problem is the one that by chopping down a forest, you're releasing all of its carbon in short order. By plowing up a prairie, you're releasing all of its carbon in short order. So you have this big burst of CO2 due to land use change going into the air. That creates what we call a carbon debt. The other thing that happens is by displacing petroleum fuels. With a biofuel, you've reduced the demand for petroleum and therefore incrementally lowered its price, thereby triggering increased petroleum demand in other markets, what we call a rebound effect. A little bit hard for people to put their brains around these days with the higher oil prices due to the disruptions going on over time and so on. There's a rebound effect. And that is kind of comparable in magnitude to some of these other effects. And so that means more CO2 elsewhere. And then typically also when you're intensifying agricultural production or putting new industrial cropland into production, you're using more fertilizer. Particular nitrogen is a fertilizer which creates N2O, nitrous oxide emissions, a very potent greenhouse gas. And then there's a whole set of other things that relate to biofuels, requiring more energy and therefore generally more greenhouse gases to produce than the fossil fuels they displace. So when you add all of that up, you end up with a situation for liquid biofuels that is pretty similar to the one that people have now assessed for forest bioenergy that can take many decades for that carbon debt to get repaid. And depending on the circumstances, and there's so much uncertainty in this, in some cases, it may not ever be repaid. We're looking at a world that is in a climate crisis. We've been talking for many years about what we need to do by mid-century. There's no way that the carbon debt from the biofuels being produced now is going to be repaid by 2050. Who knows when it's going to be repaid? I've done some simulations that suggest it might be repaid by 2070 or 2080, depending on the assumptions. There's a whole lot of uncertainty about that. But certainly in the near term that we're talking about in terms of the urgent need to mitigate greenhouse gas emissions, liquid biofuels like forest bioenergy are a net bad for the climate. They're not helpful to date.
You were very keen that we, on this podcast, that we acknowledge the quite sharp difference of opinion in the scientific community about the merits of biofuels. I just wondered if you could explain a little bit more about that and this other part of the scientific community, where they're coming from, what you think is behind that, and go into some of their arguments and how you would tackle those.
A lot of what it comes down to is that the scientific understanding 15 plus years ago, that did think biofuels were inherently carbon neutral, generated an enormous number of studies, and including many official analyses, supporting things like the Renewable Fuel Standard in the United States, the Renewable Energy Directive in Europe, and other comparable policies elsewhere. As the criticisms that I mentioned related to indirect effects and land use change, were mounted, the modelers, many of them in government agencies, government-supported agencies, made their models more complex to address those effects. And they have tended to make assumptions that minimize these adverse effects, in particular, minimize the land use change. I don't want to insinuate that they're doing this in any malicious way or anything like that. I think they come from a mindset that for years, careers that were built on it. We need biofuels, as part of the solution for energy in recent decades because of climate, but also for many years for energy security. So they've been working in the context of scientific communities that have a sense of mission, bringing biofuels into reality. And it's been very difficult for them to accept the kinds of assumptions that come from more critical studies. I really have to put this in the realm of the type of scientific debate over which reasonable men may disagree, or reasonable people, to use a more gender-neutral term, may disagree. They, by and large, have not been persuaded, or they have changed their tune in some ways. Some of the scientists that were very unabashedly, wholeheartedly for biofuels have become much more cautious about it. A lot depends on the nature of the biomass used for the fuel. How you make biomethane determines its net CO2 impact. Again, if you are making it from a crop that is in some way impacting food or feed markets, it's going to have the same adverse problems that I described for traditional crop-based biofuels made from oilseeds or maize. Certainly in the I'm most familiar with the situation in the United States. In many cases, biomethane is coming from captured landfill gas. things like that, or biodigesters set up to digest and capture the gas from manure at feedlots. In this case, you're not displacing land, to do this, and you have an added benefit of avoiding methane emissions. Biomethane made in that manner is definitely climate beneficial. Putting biomethane, even though it's a gas, under part of the biofuel umbrella, that's just one example of where it's made in a way that's clearly beneficial for the climate. The other thing that was supposedly the great hope for liquid biofuels is what is known as cellulosic biofuels.
In your research, and you've referred to the failure of cellulosic ethanol. That would be very interesting to hear a little bit about that and what happened and what conclusions you drew from that.
Well, first of all, what is cellulosic ethanol or cellulosic biofuel more generally? To date, at scale, almost all the biofuels we make are from food crops. So we're utilizing nature's easy-to-use fuels. When you're using corn or wheat, you're basically taking starch, which very easily breaks down into a sugar. It's nature's fuel. You can ferment that sugar into ethanol. The idea behind cellulosic biofuels is to use crops or crop residues that are made out of cellulosic materials, which are the structural materials for plants. They were evolved to resist breaking down and resist being respired. Natural breakdown is respiration. It's the way organisms combust for energy. And so instead of using the parts of plants that were grown by plants deliberately as a fuel, and therefore easy to process in a fuel, the idea is, we can use these other parts of plants that were designed to resist breakdown. And there's a whole lot of that around. And we could potentially grow it without competing with food crops. The quest to make cellulosic ethanol has been going on since the time of that first oil crisis of my formative years, since the 70s. And then it really ramped up also in the aughts in terms of billions of dollars were put into this idea of making cellulosic biofuels. Nature has done its job really well, and it's been extraordinarily difficult, far more difficult than the scientific community thought, to take these cellulose fibers of various forms that nature designed to keep trees standing for hundreds of years and support plant stems and the other parts of plants and convert those, into sugars. Ultimately, cellulose is, the cellulose are a bunch of interlinked sugar molecules and essentially a sugar-based polymer. But nature has done a really good job of making those resist breakdown. And so in spite of billions of dollars of effort and all the hopes, it's just not panned out in an economically viable way. In the United States, when the renewable fuel standard was expanded in legislation that was passed and signed by President George Bush in 2007, the larger part of that mandate by this year, its ultimate target year was 2022, was supposed to come from cellulosic biofuels, something like 16 billion gallons, if I'm remembering the target correctly. Well, the last time I looked at the data, something on the order of about 1 million gallons of liquid cellulosic biofuels have been produced in the United States on an annual basis. So we're talking about production on the order of 1 million compared to a target of 16 billion. We are several orders of magnitude away from reality in terms of commercial cellulosic fuels after enormous effort, billions of private and public dollars. That quest has really failed. It's still being pursued, but I don't see it panning out.
From all the things that you've said so far, we're in a kind of world which is far too focused on developing a kind of biofuel model as a climate solution.
Absolutely. I think the policies that were put in place, and in some cases they're still being put in place in the case of sustainable aviation, so-called sustainable aviation biofuels, are all premised on science that we now realize was deeply flawed.
Where next? Where can we go next with this, and where should we go next?
I am not particularly an expert on the aviation sector, and that's a tough nut to crack. We're being helped on the motor vehicle side by electrification, of course. And I think people are probably banking on that in the near term a little more than is prudent, in my view, as a long-term expert on vehicle technology. We need to be doing much more on vehicle efficiency, which we've gotten slack on. And that's, to give an example, I recently did an analysis with the US EPA data. The shift in the car market to larger and more powerful, SUVs, sport utility vehicles, and pickup trucks, which the IEA, International Energy Agency, has been for several years documenting is happening globally, not just in the United States. That shift to larger, more powerful, and more fuel-consumptive vehicles has wiped out the potential gains from EVs to date 3 times over. So there's no magic technological solution to unsustainable consumption habits, including air travel all over the place, as if we can magically offset that CO2 with biofuels or offsets. Offsets properly done have a role to play, but again, that turns out to be much more complicated than people thought. I'm certainly a big believer that, with land and the limited land resources, we need what we call the natural climate solutions, avoiding land use change and properly reforesting, where we can. And to the extent that you can generate some offsets there in the near term, that's a better near-term solution than biofuels, in my view, for sure. But land-based solutions, they're not necessarily permanent either. There's risks there as we end up tragically in a warming world where natural lands are burning at uncontrolled rates in various places. I just read about a recent study, with California, which has been a leader in climate policy, that the fires in California over the last few years have wiped out nearly a third of California's CO2 reduction goals to date. So it really goes back to sort of the basics that are tough for policymakers to swallow about reining in consumption, by doing things that are more, either more efficient vehicles or more efficient modes of transport, rail, which you can electrify rather than air. I just don't see how we're going to have a sustainable aviation industry growing globally at the rate that it has been growing. You can electrify some short-range stuff and we'll start having little, short-range drones, but it's not where the action is in terms of aviation. A lot of aviation is globalized, freight economy and so on. So biofuels are not the panacea that they have been held out to be in aviation or anywhere else.
Thanks to Professor DeCicco for his time. If you want to learn more about this topic, there's further suggested reading in our podcast blurb, including some of Professor DeCicco's papers. There's also more you can read related to this on our website at elc-insight.org, including a collection of explainers and articles on forest bioenergy, and a recent podcast on climate and the aviation sector. We think we're only touching the surface of bioenergy and biofuels, so in future episodes we hope to be speaking to more experts to get a deeper insight into some of the issues raised in this podcast. And if you enjoyed the episode, please do follow us on your podcast platforms, and we'll be back soon with more interviews with climate or environmental experts. Thanks for listening.